All right, so here we are on chapter 2 on describing change, rates, and this is section 2.6 on rate of change graphs. So every smooth continuous curve with no vertical tangent lines has a slope associated with each point on that curve. And then if we take each of those points with the slope, the resulting curve is going to be called a slope graph, a rate of change graph, or a derivative graph. Okay, now if you remember a while back, we found the min or max taking derivatives, and that graph that resulted in it that showed where the kind of the peak was, and that was the max, or if it showed it down below, it was the min. We can take and do derivatives of equations and get the derivative graph. And so we could have, we could graph the original graph, and then we could take the derivative, and that's going to be the slope graph. That's going to be the same thing. Now, some important points or intervals to consider when observing functions for slope behavior are points that when a tangent line is horizontal. So those are going to be nice because we know when it's a horizontal, we get slope is equal to 0. Intervals over which the graph is increasing or decreasing. So, if it's increasing or decreasing, we know that's how it's going to be on the slope graph. Points of inflection, that's going to be a key one. That's going to be when it gets to be 0. And then places which the graph appear to be horizontal or leveling off. So those are all four key things on that's going to help us kind of get our points from a graph. Now, information about the slope graph can be deduced from the graph F shown to the right. So we're going to start with this graph, and it looks like it's probably cubic. So if it keeps going down and up, it's probably cubic. Now, when we take the derivative of a cubic, if we go through all that, plus h and the closest point thing, we're going to end up with, if we say we start with an x cubed, and what's going to happen is we're going to get some kind of an x squared out of it. We're not going to say, we're just going to say some ax cubed, and it's going to be some bx squared because we don't know what a is. We don't know what b is either. But when we get done with this is going to look like a quadratic when we take and find the slope. So if we get something that doesn't look like a quadratic and it's uh, uh, um, the cubic to start with, then we've probably done something wrong. So that's kind of a key. And then if we started with, say, a quadratic, what's going to happen is we're going to come down and we're going to get some linear function. And if we start with some x to the fourth, we should get some cubic, and so on. So usually it's going to go, become, if we take the derivative of it, we're going to get something with 1 power lower like this. So if we start with a quadratic, we get linear, cubic, we get a quadratic, quartic, we get a cubic, and so on. All right, so the tangent lines at the point which with inputs A and C are going to be horizontal because, those are going to be the horizontal ones. So that's going to give us slope 0. So f prime of A and f prime of C are both equal to 0. Now between 0 and A, what's happening? What is our slope? Well, our slope is increasing, so the slope is positive. Now the tangent lines become less steep, or basically your slopes become smaller as your x approaches A. So it's the most steep here, and then it gets less steep and less steep, and pretty soon it's getting almost to be that 0 slope. So we can say, it's decreasing as we go up. So for 0 less than x less than a, f prime is positive and decreasing. Okay, so what's going to happen is we're going to have something like that. So, if this is our 0, we're decreasing and we're staying positive, okay? Now between A and C, the graph is doing what? Well, here's A, here's C. It's going down. Okay, so we're decreasing. Now the slopes are all going to be negative. So, A less than X less than C, F prime is negative. So we're going to have negative slopes. Now this key point right here, there's an inflection point. Now this is the point where the graph is decreasing the most rapidly. So f prime of b is going to be our, in this case, lowest point. So if we have a graph and it's going to be, and it's a negative, it's going to be the lowest point, and so it's going to come down and it's going to be the lowest one. Now between C and going to the right, what's happening? Well, it's increasing again. It starts out slow, then it goes higher and higher and gets steeper as we go to the right. And so basically, our x is going to be greater than c, f prime is positive and increasing. So what's going to happen is we're going to kind of come back up here again like that. And so we've kind of looked at this. We have, this is at point A, this is at point C, this is at point B, that's our minimum. And these are how it's going. It's getting less and less steep. So, if this is our steepness over here, or our slope, however you want to look at it, if we start here, it's going to be really, really steep. Now, this is off the graph. So, the first ones are going to be the most steep because it's going to be the highest. And then somewhere, halfway between 0 and 1, it's going to be, maybe here. So it's going to be a little less. And from here to here, then while we're going to hit 0, then we're going down and then we're going back up again. So that's kind of how it is. And if we come over here, that's what we're doing here. We're plotting these points that we can kind of gather. We know it's the most positive, the closest over here to this axis, whatever it is. And again, it's not always going to be at 0. Sometimes it's going to be something else, but it's going to be the most positive over on the left side. And then as we go and progress further, it's going to be less positive, and then it's going to be less positive. Then we know it's going to be 0 here and 0 here, so we can just put those dots already. We don't have to worry about that. And then it's going to get negative, and it's going to get most negative at that inflection point. So that's the point where it's going to be the most negative. And then after that, it's still negative as we go up a little bit. And then pretty soon we're back to 0. So if we look over here, you know, that's where it hits the most negative. But we're still negative here, but we're going less and less and less. We're getting closer and closer to 0. And so that's what we're doing here. We're getting less and less negative. So, this is the most negative. So maybe that's a -5. And this one is maybe only a -2. And then pretty soon we hit that 0. And then we're positive again. And so if we look at our graph, it's going to look something like that. And so this is the quadratic that we would get from that original graph that was a cubic. Okay. Now, slope graphs of functions with bounded end behavior. The end behavior of a function affects the shape of its slope graph. Okay, so that's the key thing. And the function graphs from rate of change information. When functions are increasing, the slope graph is positive. When functions are decreasing, the slope graph is negative. Okay, so it's kind of, it's negative down here, positive up here. So we kind of have to remember that as far as that goes. And so what we kind of have to think about is this is kind of an example on what's happening here. So we have a negative slopes. All of these are all negative. But what's happening? Well, as we get closer and closer here, it's getting closer to 0 because if we reach a point here and all of a sudden it comes back up, that would be a 0. So our slope is getting closer and closer to 0. But what's happening? Well, it's very steep at the beginning, then it gets less steep. Now they're all negative, so we have to say, okay, well, up here is positives, down here is our negatives. So we have everything below that line there. So we're kind of over here in this last quadrant on the bottom right. And so what happens is it's the most steep here. So that would kind of result here. That's the most steep. And so that's going to be the most negative. Now this one here, it's less steep than that one. So then it's less steep. And so it comes up here and it's not as negative as that one. And then that one's less negative even yet. So then, it's here. So it's less negative than this one. And then this one's even getting closer to 0. And so it's getting closer to 0. And so then our shape is going to look something like that. And again, we're down here in the negatives. The positives are up here. So that's why we have it drawn below here, because we have only negative slopes here. And this is kind of a similar one, but what we want to do is kind of differentiate, increasing versus decreasing. This one, it was decreasing, it was getting closer and closer to 0. So the slope steepness was slowly going smaller. Now this one here, if we think about it, that would be 0 slope. And then it's a little bit more, a little bit more, a little bit more, and it's going to get steeper and steeper as we go down, which means at this point here, that's going to be the most negative slope at that point. And so, if we had put that over here, that's the most negative. So that's the most negative number. This one, it's still negative, but it's not as negative as that one. So it's about here and here and then we have that one's at that point. And so, this is how it's going down, and that ends up being how the shape of the curve is. And remember, this is the negative part, this is the positive part, and so we're always in the negatives, and getting steeper means we're getting more negative, okay? All right. Now, while a smooth continuous curve has infinitely many points, we could choose from to find all the tangent lines too. We're not going to do that. We're only going to find a few key ones, and then we're just going to draw our curve from there, okay? Our slope curve. So what happens usually, they're going to have some marked. Those are the key ones we'll probably use. And so in this case, we'll do a 1, an A, a B, a C, and a 6. And so we'll mark that on the new graph. Now, we were not going to plot it yet, but that's how we're going to do it. And then after that, we actually have to go and say, okay, at this point here, what is the slope of that tangent line? So we actually have to go back into the old method and do our graphing and say, okay, well, the slope is, from here to here, and it gives us that point, and we get the slope. And in this case, they gave us the slope was about 2.7. So 2.7, and it's positive. So, again, we're up here is positives, down here, we're in the negatives. So we have to really differentiate that. Now, what do we know about this point? Well, that's going to be 0. That's going to be 0. This is going to be the most negative slope. And so, we're going to draw, it's going to kind of go through that inflection point, kind of come down through there. That's going to be the most negative. And when they do that, they found it's about negative 1.4. And so that's going to be that point here. We have our two zeros, are negative 1.4 or 1.27. And then what we're going to do is at 6, we'll do another one. And that one, we'll figure out the slope again, whatever that point is, and they found it to be about 1.8 on theirs. And from there, we can draw our nice smooth quadratic. And again, if we think about this, it's a cubic in nature, and so if we're x cubed to start with, when we take the derivative, it's going to be some x squared, so it's going to be a quadratic, and so we should get a quadratic in shape there. And that inflection point is going to be either the min or the max, depending on if it's on a decreasing side or if it's on an increasing side. All right, now sometimes you just get a bunch of dots, okay? And so the dots really don't help us at all because, we don't know what the smooth curve is there. And so what we have to do is we actually have to just kind of hand draw in a curve. Now, you know how I can hand draw, not very well, but that's what we're going to have to do on some of these. And then from there, we're going to use the curve to kind of find our tangent line. So then, we could then do a tangent here, then we can have some kind of inflection point somewhere in here. And we'll have that's going to be 0, 0 there. And then we're going to come down here. Now, this one's coming up, coming down. And it looks like it might be, doing something like this. It's not a going straight back down. It looks like it might come back up again. We're not sure, but that's kind of how we're gonna have to start, doing it. And so we'll have some kind of uh, you know, or inflection point there, horizontal, things like that. So sometimes you will have to draw in a curve before you can actually find those tangent line slopes. All right, so there's also 2 points usually. These are the two key ones of undefined slope. Now it's possible for the graph of a function to have a point where the slope doesn't exist. And we know sharp corner is one of those. That's a good example. We've seen that one before. So there is going to be a place where the slope doesn't exist. And there is also one. If we look at that, that's what it looks like here, kind of here. So the derivative doesn't exist at that point, and so the slope function is non-differentiable at that point. And so we get this kind of open spot here. So we don't have that key thing because it's coming down here, it's a big negative slope here, but coming from this direction, it's a positive slope. So we have that positive slope showing here, but we have an open circle, and then we have that negative slope coming down like that, and we have an open circle, and then there's that big break at the point A because of that sharp corner there. Now these are kind of some other examples. The other key one is if we have a vertical tangent, that's not going to have a slope that's undefined. That break here, that's undefined. This open circle here, that's undefined. Now they kind of show us, on each of these, if you have that break, you get this kind of actual f prime of x, graph, or it's your slope graph. But you can also have something like this over here as well. This could be f of x is that, and then you have the open break, and then you'd have to figure out what your slope graph would look like from there. Again, this is undefined because we have a vertical tangent, and so it's perpendicular thing is it's going to have the asymptote at a, and vertical asymptote, and so it's going to kind of go up, and it's never going to touch that A, and it's going to come down. It's never touching it, and then it goes down that way. So sometimes you graphing these are going to be a little more difficult just because you have to think about that's increasing, increasing, and then it goes pretty close to vertical, and so it's increasing, increasing, then it goes pretty close to vertical, and here it's pretty close to vertical, and then it's kind of decreasing because this one, we're increasing positive, and this one we're decreasing positive. So then we'll be coming down and going that direction. All right, so let's stop there and we'll come back for more.